When you gaze up at the night sky, it's easy to imagine the universe as a tidy place. A vast dark room filled with neatly arranged galaxies like cosmic chandeliers hanging in their designated spots. We often think of it as having a beginning, a middle, and maybe even an end, a final, definitive edge where everything just stops. But the cosmos isn't like that at all. It's not a well-kept garden. It's a wild, untamed frontier. There is no cosmic shoreline where the universal ocean ends. Instead, it is a boundless expanse, constantly evolving, shifting, and surprising us with phenomena that defy our neatest categorizations and expectations. This wildness means that the universe is full of wanderers, objects untethered from the gravitational anchors we thought were permanent. We expect to find the biggest things like supermassive black holes, sitting obediently at the centers of their host galaxies. They are the gravitational heart of their stellar cities. But the universe has other plans. Recently, astronomers witnessed something that shatters this tidy picture. They found a monster on the loose, a supermassive black hole roaming in the lonely darkness between galaxies. This discovery reminds us that the cosmos is far more dynamic and chaotic than we ever imagined, a place where even the most massive objects can be cast out into the void. This rogue black hole wasn't just silently drifting, it was hungry. Scientists caught it in the act of committing a spectacular cosmic crime, devouring an entire star. This wasn't happening in the bustling downtown of a galactic metropolis, but in the quiet, dark suburbs of the universe. Imagine finding a great white shark not in the ocean, but in a small, isolated pond. That's the level of surprise we're talking about here. This event, so far from where we expected it, forces us to reconsider the life cycles of galaxies and the powerful gravitational tug-of-wars that can eject their most massive inhabitants into the great cosmic unknown. So, let's journey together to the scene of this incredible event. We need to leave behind our comforting ideas of a predictable, orderly universe. Instead, we must embrace a cosmos that is messy, unpredictable, and full of hidden dramas playing out in the darkest corners. This isn't just a story about a single wayward black hole. It's a story that redefines our understanding of cosmic structure and the powerful unseen forces that shape the universe. It's a reminder that there are always more wonders and more terrors waiting to be discovered in the deep dark. To understand this discovery, we first need to talk about what a black hole is. Forget the sci-fi image of a cosmic vacuum cleaner. A black hole is simply a place where gravity has become so incredibly strong that nothing, not even light, can escape its pull. It's what's left over when a truly massive star dies and its core collapses under its own weight, squeezing an immense amount of matter into an infinitesimally small space. Supermassive black holes are the titans of this family, millions or even billions of times more massive than our Sun. They are the gravitational anchors at the heart of nearly every large galaxy, including our own Milky Way. Now, what happens when an unlucky star gets too close to one of these gravitational behemoths? It experiences something called a tidal disruption event, or TD. You know how the moon's gravity pulls on Earth's oceans to create tides? Imagine that force amplified 1,000,000,000 times over. As the star approaches the black hole, the gravitational pull on the side of the star closer to the black hole is far stronger than the pull on the far side. This immense difference in force stretches the star, pulling it apart layer by layer until it's unraveled into a long glowing stream of gas. This process is not a quiet one. As the stellar material gets pulled into a swirling disk around the black hole, like water spiraling down a drain, it heats up to millions of degrees. The intense friction and compression cause the material to glow incredibly brightly, releasing a brilliant flash of energy across the electromagnetic spectrum, from X-rays to radio waves. This flare of light is the cosmic scream of a dying star, a beacon that can be seen across vast distances. It is this flash that acts as a cosmic bat signal, alerting our telescopes on Earth that a tidal disruption event is underway, even if the black hole itself remains invisible. The event astronomers witnessed, which they named J 21500551, was a textbook example of this stellar shredding, but its location was anything but ordinary. Typically, we see these events happen in the crowded centers of galaxies, where stars and a central supermassive black hole are packed closely together. But this cosmic feast was happening in the middle of nowhere, far from the light of any major galaxy. It was a clear sign that the perpetrator was not a well-behaved black hole, but a rogue, a wanderer, moving through the intergalactic darkness, a true monster at the edge of its former home. Observing an event like this is a marvel of modern astronomy. It takes a team of powerful eyes in the sky, all working together to piece together the story. The first hint of this cosmic drama came from a survey telescope that scans the sky for transient events, things that suddenly flare up and then fade away. Once this initial flash was detected, a cosmic alert went out, and astronomers quickly aimed some of our most powerful observatories, including NASA's Hubble Space Telescope and the Chandra X-ray Observatory, toward the source. They needed to gather as much information as possible before the evidence, the light from the shredded star, faded away into the darkness forever. What these telescopes saw confirmed their suspicions. The light signature was a perfect match for a tidal disruption event. The data showed a supermassive black hole, about 100,000 times the mass of our Sun, surrounded by the glowing, superheated remnants of a star it had recently torn apart. But when they looked closer with Hubble for the black hole's home galaxy, they found nothing. There was no large, bright galaxy at that location. Instead, the black hole appeared to be located in what might be a tiny, faint dwarf galaxy, or perhaps it was completely untethered, drifting alone in the void. This is what makes this discovery so groundbreaking. Supermassive black holes of this size are not supposed to exist outside of large galaxies. They are thought to grow along with their galactic hosts over billions of years. Finding one on its own is like finding a skyscraper in the middle of an empty desert. It suggests a violent past. The most likely explanation is that this black hole was once at the center of a galaxy that collided with a larger one. In the gravitational chaos of the merger, the smaller black hole was slingshotted out, ejected from its home and sent hurtling through intergalactic space. This cosmic fugitive was caught red-handed about 600 million light-years from Earth. Now, that number sounds immense, and it is. A light-year is the distance light travels in 1 year, which is nearly 6 trillion miles. So we are seeing an event that actually happened 600 million years ago, when the first complex animals were just beginning to appear on Earth. The light from that stellar death has been traveling across the universe ever since, finally reaching our telescopes. It's a profound look back in time, giving us a front-row seat to a drama that unfolded long, long ago. While 600 million light-years is an incredible distance, it's important to understand this is in our relative cosmic neighborhood, not at the edge of the universe. The observable universe stretches out for more than 46 billion light-years in every direction. This event didn't happen at some ultimate boundary, but within the vast established web of cosmic structure. Its significance comes from its location, not in space, but relative to its galactic home. Its lonely position in the intergalactic medium tells us that the universe is a more unruly and chaotic place than our models once suggested. Galaxy collisions we now see can have consequences far more extreme than we knew. This discovery implies that there could be a hidden population of wandering supermassive black holes drifting silently between galaxies. They are dark, invisible, and only reveal themselves when they happen to consume a passing star. How many more of these cosmic vagabonds are out there? Are they a common feature of the universe, a natural byproduct of galactic evolution? These are the new questions that keep astronomers up at night. This single event has opened up a whole new field of study. The search for the universe's lost, homeless monsters. We have just pulled back a curtain on a previously unseen aspect of the cosmos. Before you start worrying about a rogue black hole paying a visit to our solar system, you can rest easy. We are perfectly safe. The vastness of space is our greatest shield. The distances between stars, even within our own galaxy, are immense. The probability of a wandering black hole coming anywhere near us is infinitesimally small. Our own supermassive black hole, Sagittarius A*, is held securely at the center of the Milky Way, 26,000 light-years away. This rogue black hole is a fascinating cosmic spectacle, but it poses absolutely no threat to us here on our pale blue dot. Ultimately, this discovery is a beautiful example of what science is all about. We build models of the universe based on what we can see, but a single unexpected observation can suddenly reveal that the picture is much bigger, much wilder, and infinitely more interesting. The universe isn't a static, finished painting. It is a living, breathing, evolving entity full of surprises. Finding a star-eating monster in the dark reminds us that there are still profound mysteries out there, waiting in the void. And it's our privilege as curious explorers on this small world to keep looking up and asking questions.